Hi everyone. Next we are moving to the chapter number 5, passive circuit element test series. Here also 20 questions explanation will be present. So the first one, question number 1, the 4 band color code on a carbon composite resistor is as follows. So here first band, second, third and fourth band. So the first band will be yellow, the second band will be violet, third band red and fourth band is a silver. So based on this color code, what is the value of resistor you need to identify. So in the theory class, I gave the color coding concept deeply as well as table I provided, and then I gave the one logic to remember: BB Roy go to Bombay via Goa to away. You need to remember the particular code. You can answer any question. So here according to that, yellow value is a 4 and violet is a 7, as well as first two are the digits. Keep it right as it is. Third band is a multiplier. So red multiplier is 10 power 2. And the fourth band is a tolerance. It is silver. It is a plus or minus 10%. Okay. So multiplier is 10 power 2 plus or minus 10% ohms. So from that, resistance R is equal to 10 power 2, that is a 4.7, 10 power 3.7, 10 power 3, that is a kilo plus or minus 10% ohms. So which option is correct? Option 4.7 plus or minus 10k. Option B is the correct option. Okay, next we are moving to the question number 2. So before moving to the question number 2, so I gave the one link to link in the video description. So Telegram channel link is there. If you want this PDF, all PDFs available in this particular Telegram channel. So I will provide the link. As well as today also the offer is continue, 50% offer plus installment offer is also there. If you are really interested, you can download our mobile app and then go through our course. Okay, question number 2. In the question number 2, which of the following is a correct statement? So the correct statement is, by looking at the diagram, this is a positive polarity, this is a positive polarity. Whenever two positive polarities are connected together, what will happen? These are the series connection. It is a subtraction because same polarities are repel each other, opposite polarities are attract each other, means it is a opposite polarity. Repel means that subtraction. So 5 minus 5, the voltage becomes 0 volt. Now our equivalent circuit diagram will be, voltage is removed, the cases. So what are the elements are present? 2 ohms and 2 ohm. Resistance only present. Look at the options: passive and linear, active and linear, passive and non-linear, and active and non-linear. Out of this, option A is correct, because if resistors are passive elements, resistors are linear elements also. Option A is the correct option. Okay. Next, the coupling between two magnetically coupled coils said to be ideal. The coefficient of coupling. The coefficient of coupling is 1. K is equal to 1. Then, so coefficient of coupling will be K is equal to 1. Then only it is an ideal case. K is equal to 1. Coefficient of coupling is equal to 1. Option C is the correct. You know that formula. K is equal to M divided by root L1 L2. So in this case, there is no total entire flux linked with both the coils. There is no loss of flux. So K value is equal to 1. So I explained in the theory. It is a detailed manner. Just go through that. It is enough explanation here. Should remember, whenever ideal case, magnetically coupled between the two coils, coefficient of coupling is equal to 1. Next we are moving to the question number 4. The voltage and current waveforms of for element shown in the figure. So here two waveforms are given for the particular element. For example, you don't know that element. In case the relation between these two is a differentiation, right? Di by dt. So differentiation is available for the response of voltage. The formula V is equal to L into di by dt, right? If here this particular waveform is related to this particular formula, that means it is an inductor. They are asking about what is the element inductor. Of course, the value you need to find out. You can find out the value. So V from that waveform response is 2 volt. You don't know L value. What is the di by dt? The response is 2 ampere per second. So 2 amperes by 2 seconds. That will be L is equal to 2. From that, L is equal to 2 Henry. So it is inductor, it is a 2 Henry. Next question number 5. If current through the resistor is off, what is developed by it would be? So for example, I will consider this is a resistor. Resistor is R. The current will be I. So this current will be reduced to 1 by half. So initially P is equal to I square R. This is the actual formula. Now if this power is reduced to, current will be reduced to 1 by 2, half of whole square into R. That means 1 by 4 I square R. You know what is I square R? I square R is equal to 1 by 4 P. So power at off load will be equivalent to 1 by 4 times of full load. Right, that means 1/4 cut to 1/4, 1 by 4. Option C is the correct option. Next we are moving to the question number 6. In the question number 6, the carbon composition resistor shown in the figure, the resistance value will be. So in this particular diagram, color coding is given. You need to find out the resistance value. Here also yellow is provided, violet and yellow as well as silver, right? So here yellow is 4 from the table, violet is 7. First two are the as it is you can write. Violet again yellow as a multiplier in the third band is it is a multiplier, 10 power 4, and silver plus or minus 10%. That means here into 10 power 4 plus or minus 10%. Right? So just look at the options. Every option is a kilo. That's why it is converting to kilo. 470 kilo. Right? Plus or minus. Here if any 470 is there, yes, it is a 470 is there, but it is not in terms of percentage. It in terms of tolerance, in terms of ohms only. That's why it is not in terms of ohms. In terms of 40 numerical value, it is K, not ohm. So see here. So percentage I convert into ohms. 470 K divided by what is the percentage? 10%. So just cancel. It is a 47 K. What is the option? Option C is the correct option. In the examination, this type of questions will be there. The concept, but where you need to apply according to the options, you are going to get the solution. Just see the options also sometimes. Okay, next question number 7. In the question number 7, the color code of a resistor shown in the figure. Yes, the just identify the value color code values. So here 33 K plus or minus 5% tolerance, right? 3 is orange, right? 3 is orange, and 10 K is nothing but a 10 power 3. 10 power 3 is nothing but a orange only. Okay, multiplier is orange. So 3 oranges, as well as what about the 5% is a gold. So finally what is the color? 3 oranges as well as 1 gold. Option C is the correct option. Okay, next we are moving to the question number 8. In the question number 8, the combined resistance of two resistors. So here first resistor brown, red and brown. Brown is a 1, red is a 2 brown is a 10 power 1, that is a 120 ohms. So yet there is no color, tolerance is plus or minus 20%, but in the options tolerance is not mentioned, that's why don't forget, just don't want tolerance here, forgot about tolerance. Next, violet, yellow, green and black. Yellow is 4, green is 5, brown, black is 10 power 0, that means 45 10 power 0 is 1, 45 ohms. Those two are connected in series, so 120 plus 45, 165 ohms. So option C is the correct option. Next, when checked with the ohmmeter, an open resistor reads, that means in case of this particular resistor, it is opened. We have connected the ohmmeter here. Ohmmeter shows resistance value is infinity. So that means whenever the ohmmeter is connected to the open circuited resistor, resistance shows the infinity. Open circuited resistance is infinity. Next, question number 10. The question number 10, while measuring the resistance with ohmmeter, yes, one should not touch with the test leads, because while you are measuring the resistance with the help of the ohmmeter, for example, this is a ohmmeter, one of the person stand here and then measure, this particular hands touch to these particular leads, what will happen? Total entire resistor parallel with this particular person. Whenever this resistance value parallel with some person resistance value, what will happen? Resistance decreases. That's what here. It may be lower the ohm. It is a resistance value lower the actual value, because parallelly, right? So option B is the correct option. See the of the possibility of electric shock, no, it is not possible. You can touch, there is no electrical shock, from the laboratory. It may be ground the resistor, no. It may be short circuit resistor being checked, no. It is a lower the ohmmeter reading, that is the effect. Next, ferrite core commonly used, ferrite core commonly used decrease the core losses, because ferrite element I discussed in the theory class, it reduces the hysteresis and eddy current loss. Indirectly, core losses will be reduced. Core losses is a combination of hysteresis and eddy current losses. So next one, point out incorrect answer. Inductance of a coil depends. So the what we call formula for inductance, L is equal to mu naught mu r L square A by L, right? So see here, the first option directly proportional to the number of turns, square of the number of turns, directly proportional to the, yes, option is correct, but you need to identify incorrect option. Directly on cross sectional area of the core, yes, so this is also correct only. Directly on thickness, any thickness is there related directly proportional, no, so this option is incorrect. Next, inversely of the square of the length, yes, it is inversely. So which option is correct? Option C is the correct option. Next, question number 13. In the question number 13, a coil has an inductance of 1 Henry. Inductance is equal to 1 Henry as well. The current charging at the rate I is equal to 2 ampere per second. So what they are asking, voltage. V is equal to L into di by dt. From that, you don't know voltage, but inductance, di by dt is a 2 amperes. That will be equivalent to what is the voltage? 2 volt. So 2 volt is the answer. Option C is the correct option. Okay. Next, moving to the question number 14. In the question number 14, a coil 2 ohms developed counter EMF 4 volt in it. So we have a coil. It is a 2 Henry. What is a counter EMF? 4 volt. Its rate of charge of current through it must be dash ampere per second. L value, V value. So from that, V is equal to L into di by dt. You want to find out rate of change. So V is equal to 4 volt L is equal to 2 di by dt. From that, di by dt is equal to 4 by 2, that is a 2 ampere per second. So it is a 2 ampere per second. Option A is the correct option. Okay. Next you are moving to the question number 15. In the question number 15, the reactance of a coil at 100 Hz is 20 ohms. That means XL is equal to 2 pi FL. I gave the formula in the theory class. What is the XL value? Inductive reactance 20. 2 pi, frequency is 100 into L value. From that L is equal to, you will get 0.0318 Henry. This is the first case. In case if reactance at 1 kilohertz, if frequency is 1 kilohertz, what about the inductive reactance? That will be XL is equal to 2 pi, frequency is 1000, right? 1000 Hz into L value is 0.318. From that we can value 119.99 ohms, that approximately 200 ohms. What is the answer? Option D is the correct option. Okay, question number 16. The main function of capacitor, the main function of capacitor is a store charge energy. That is option C is the correct option. Here storage of energy in terms of electric charge. Next we are moving to the question number 17. A capacitor stores 0.5 coulombs at 10 volt. The capacitance will be, Q is equal to CV. What is the charge? 0.5. You need to find out the capacitance. What is the V? 10 volt. From that, C is equal to 0.5 divided by 10. That is equal to 0.05 farad. 0.05 farad. Option C D is the correct option. Next we are moving to the question number 18. Two inductive coils, self-inductance L1 and L2 are magnetically coupled in series opposition and parallel aiding. Series opposition, parallel aiding. The mutual inductance between the coils is M. The equivalent inductance in the two cases, it is easy. Inductance in opposition. First case opposition. Whenever it is opposes in series, the formula L1 plus L2 minus 2M. It is in case of opposition. In case of parallel aiding, the formula will be L1 L2 minus M square divided by L1 plus L2 minus 2M. So option C is the correct option. Okay. Next we are moving to the question number 19. The coil having a self-inductance of 10 millihenry and 15 millihenry, effective inductance is 40 millihenry. When connected in series aiding, what will be the equivalent inductance when connected with series opposing? Two cases are given. First of all, series aiding. Just find out the series aiding. Series aiding, L equivalent is equal to L1 plus L2 plus aiding plus 2M. Opposing minus 2M. So that value is given 40, right? So 40 is equal to, what is L1? 10 plus 10 plus 2M. What is the 2M value now? 2M is equal to 10 millihenry. 2M value is equal to 15 millihenry. You got, right? So now series opposing. Whenever series opposing, the formula L1 plus L2 minus 2M. What is L1 plus L2? 10 plus 10 minus 2M. What is the 2M? Directly we can write 15M. That will be equivalent to, here L2 is 15, right? It is okay. It is 15. That will be equivalent to 10 millihenry. What is the answer? Option B is the correct option, 10 millihenry. Next we are moving to the last question. Here the condensers, that means capacitor, 20 microfarad and 40 microfarad connected in series across 90 volt. After charging, they are removed from the supply. After charging, they are okay. It is repeated. They are removing them from the supply, are connected together and similar negative terminal. Then the voltage across will be. So first we are finding the charge value whenever it is connected in series. It is charging, right? What is the input voltage we are connected? The input voltage we are connected 90 volt. The capacitance value is 20 microfarad. Here also 40 microfarad, right? As well as plus and minus V1, plus and minus V2. So first of all, I am going to calculate the charge. First I am going to calculate V1. V1 is equal to voltage division rule, 90 into, in case of current, in case of voltage division rule, in case of resistor, the same value of resistance divided by our total resistance. But in case of capacitor here, 90 into, you want to find out V1. Second capacitor you need to consider 40 divided by, all are micro, right? 40 plus 60 microfarad, that will be equivalent to 60 volt. Coming to V2. So you want V2 opposite capacitor, total voltage into 20, opposite to the resistance voltage division rule, by 60 micro, that will be equivalent to 30 volt, right? So you got V1 and V2. From that, Q is equal to, Q1 is equal to V1 C1. What is V1? 60 into capacitor is 20 micro, that will be equivalent to 120 1200 microcoulomb. Coming to Q2, V2 into C2. What is the V2? 30. What is the C2? 40. That is a 1200 microcoulomb. So I got the capacitance value of charge values of this particular capacitor. Whenever it is removed, the charge remains same. So that will be connected in parallel aiding two negative terminals connected together, right? So this is a 40 microfarad, this is a 20 microfarad, as well as you need to find out this Vx voltage. So Q1, Q2 values are known values. From that, total charge is equal to 1200 plus 1200. That will be equivalent to 2400 microcoulomb. Whenever it is 2400, total capacitance also, whenever connected in parallel, capacitance is added, right? Just go to the theory class, I explained there. It is a 60 microfarad. So once you got 60 microfarad, therefore Vx is equal to Q total divided by capacitance. What is the Q total? 2400 divided by capacitance is 60. That will be equivalent to 40 volt. So what is the option now? 40 volt is the answer. Option C is the correct option. Okay. This is about explanation about the unit number 5. Still we completed unit 5, numerical problem, conventional problems, as well as all theory concept. Everything is completed. If you are really interested in our app, just download it, and then we are providing the installment. Those are economically weak, I provide the installment also. Thank you.